Hi and welcome to my video on solving linear equations. I'm just going to look at some simple ones, but we'll probably break through some examples that include up to variables on both sides and some brackets. Okay, but let's just start talking about the idea of solving equations. So my first example is going to be this one here. X plus 6 equals 10. You've seen plenty of things like this, and I know you can already do this question. But let's talk about the point and where we're heading and the ideas behind it. Okay? So for solving an equation, what we're actually saying here is that something equals something else. They're equivalent. There's an equivalency. And this something is x plus 6, and this something is 10. And we can think about it like this, like a set of balanced scales. So those scales are sitting there, and if this was bigger, it would tilt. If this was bigger, it would tilt that way, but we have an equal sign. So they're actually equivalent. But with the set of scales, imagine this for a second. If I got this 6, let's imagine that 6 was not actually 6, but it was 6 blocks. And I shouldn't have chosen 6, I see now, I should have chosen 2. But anyway, okay, I'll get my 6 blocks, and let's imagine this 10 is not actually 10, but it's 10 blocks. Okay, 10, whatever the 10 blocks are, maybe they're sugar cubes, maybe they're dice, perhaps, I don't know. Okay, anyway, you've got 10 blocks, you've got 6 blocks. Now, if I remove these 6 blocks on this side, then the scale goes bam, like that, because this is now heavier. So to even it back out again, I have to move 6 blocks on this side, and that leaves me just 4 blocks. Which I know you knew was the answer anyway. But the point is that I've got x plus 6. To solve this equation, I have to subtract 6. So I've got x equals 4 because I subtract 6 from both sides. And this is a communication aspect now. So it's about writing an equation and saying what you're doing to solve the equation. You notice here plus 6 and minus 6 are opposite operations. And we do opposite operations to solve linear equations. It's a bit like unwrapping a present. So we're taking the layers off the x so that the x becomes a term by itself, usually on the left-hand side by itself equal to a number. That's our goal here, okay? So that's a bit messy. Don't have to worry about the scales all the time. Let's have a look at another question. Still pretty common. It requires 2 opposite operations. 2 minus 7 equals 15. 2x minus 7 equals 15. Okay, now again, think about that analogy, unwrapping a present. The x is the present. That 2 is pretty close to the x. The minus 7 is a little bit further away, and I can probably deal with that first. So I am going to deal with that first. I'm going to add 7 to both sides of my equation, and that gives me 2x equals 22. Okay, now this working is fine. You may, if you like, write down a little plus 7. Okay, when we add or subtract a number, it just has to happen once to both sides, and that's fair and even. When we divide though, we have to make sure we divide each term. Luckily, we've got only 2 terms. So we've got 2x, which is the same as 2 times x. We're dividing by 2. Which means we divide both sides by 2, and of course that gives us x is equal to 11. Okie dokes. Now, just going to clean the board. Okay, 2 more examples on solving linear equations. The objective should be to get to here. I'm going to talk around the equations a little bit on these two because I want to show you a couple of ways you can think about it. And of course, mathematics is a brilliant subject because we can all do it in different ways and get the same answer. It's just about the logical process being mathematically correct. So in this one, I'm going to show you something. Often we are really geared towards getting x to the left-hand side. I'm going to show you that doesn't have to be the case, and in fact, sometimes there's a better decision to be made. So what I'm going to do instead is I'm going to recognise that I've got 3x and 5x, and that means I've got x on both sides of the equation. I want to eliminate that down, so I've only got x on one side of the equation, which means I can either remove the 5x from here to there, or remove the 3x from here to there by doing a subtraction. But if I subtract the 5x, I'll end up with a negative. And if I can, I'm going to avoid negatives in my x's. So what I'm going to do instead is I'm going to subtract, and I'll put this in a different colour, I'm going to subtract 3x from both sides. And that will give me, the 3x will cancel out, it will leave me with negative 7, 5x minus 3x is 2x minus 1. Then I'm going to add 1 to both sides, because that's how I remove the minus 1. And it gives me negative 6 is equal to 2x, and then I'm going to divide by 2. and that will give me negative 3 is equal to x. Now technically, there's nothing wrong with that statement. But mathematical convention would say that you probably had the x on the left-hand side at the end, so this is where I'd frustrate my class and I'd say, therefore, that's my therefore symbol, x equals negative 3. Just flip it around, that just follows those conventions. But there's a bit of a process for you in solving with x on both sides, and don't feel worried about which side x ends up on, but do make your life as easy as possible by avoiding negatives where you can. Here's my second example, and this is going to involve a bracket as well. So let's start by expanding the bracket. But before I do that, can I just make the statement here, you don't have to expand the bracket, because you could do this in a slightly different way. If I subtracted 7 from both sides, I'd be left with 2x plus 3 on one side. Then if I divide it by 2, I'm now left with x plus 3. So there are alternate ways of doing this. That would be then solvable from there, but I'm going to expand the bracket because I know that that's going to lead to fractions if I do that, and I don't really want fractions. So when I expand this bracket, I get, the distributive law tells me I get 2x plus 6 plus 7 is equal to x plus 18. And simplifying again, I get 2x plus 13 is equal to x plus 18. And then I'm going to subtract x from both sides. My lowest number of x's has been subtracted. And 2x minus x just gives me x plus 13. Now just equals 18 because I subtracted x. And now I'm going to subtract 13. Minus 13 there, and x is equal to 18 minus 13, which is 5. So there's another example of solving those linear equations. Now this whole topic is just to build up of rules. So rules that start with knowing what the opposite operations are. And once you know the opposite operations, just knowing how to unwrap that x, or deal with multiple x's by expanding it right out and getting the x terms together. The more you practice, the better you'll get at this, and it's definitely worth practicing. There's some websites out there, if you're practicing these, you can make up your own questions. You might accidentally make up a question where x isn't so nice, it's not a whole number. What does it matter though? Just write your answer as a fraction. There are websites like Wolfram Mathematics or Symbolab. If you Google those, they solve equations for you. So if you just made that up to practice, you could put it into Symbolab, it'll tell you what the answer is, and you can check to see if your answer's right. It'll even give you some steps. Definitely worth practicing these, and if you want to get really good at it, know how to make a question that gives you a whole number answer. That's your challenge. Go beyond the doing and be the person who's thinking about how to create good questions. That's how you get good at something. Anyway, I hope that's pretty clear to you, and all the best.